We are doing a lecture series of different chapters, okay, of different classes. So in this series, actually, we are doing structure of atoms. Okay, this is the lecture 2 of structure of atom chapter of class 9th. Okay, where we are learning, um, like we already learned the basic introduction of what are the different subatomic particles. Okay, now in this lecture we are going to learn these topics, that is discovery of electrons in like cathode ray experiment, okay, and the determination of charge and mass of electron, how this charge and mass of electron is determined, then Millikans oil drop experiment, and then finally determination of mass of electrons. Okay, so we know that electrons have -1 unit of charge and 0 unit of mass, but it they have like very negligible mass. Okay, they have some mass which is, you can say, very negligible as compared to the mass of neutron and proton, but they do have their own like very small mass. So how this mass of electron was determined, okay, and then what was the how the charge was determined, this is all like we are going to study in today's lecture. Okay, so yeah, hi, welcome everybody. I am Ashutosh, and I am going to teach chemistry to you all, and this is the second lecture of this chapter, structure of atom, of class 9th. Okay, so let's start. Discovery of electron, cathode ray experiment. So cathode ray experiment was performed, you can say, like this. Okay, so if we draw a cathode ray tube like this, okay, with connection to a battery like this, okay, with a positive and a negative, when this also this is a cathode ray tube, and then we are going to have very low pressure inside by, yes, very low pressure inside. So what happens when we connect this whole arrangement in to a let's say very small, very large voltage, okay, like 20,000 volt. Okay, so then what will happen? The rays, so these electrons will start moving from, let's say, one of the plate or electrodes to other electrode. Okay, so the every time the electrons are going to emerge from cathode, okay, towards and move towards anode always, okay, like this. That's why they are called cathode. Why cathode rays? Why? Because every time whenever you made this setup, okay, every time these rays are going to evolve from cathode only. That's why they are called cathode rays. So it was observed that there are like various properties associated with these cathode rays, like they are like one of the properties is that whenever we put something, okay, some let's say some, let's say, object, so they are going to cast shadow. Okay, so they are going to cast shadow of these object coming in between their path. Okay, so these are like some of the properties by which uh, the scientists concluded that what are the various properties of cathode rays. So one of the properties what was cathode rays are negatively charged. Cathode rays are negatively charged particles. Okay, they are particles, they are individual particles, okay, moving from cathode to anode. Okay, clear? Then later it was found that these particles, these individual particles are called electrons. These individual particles are called electrons. Okay, and that's how these electrons are discovered. Okay, we can say that this electrons are discovered like this. Okay, then next slide. So I actually made this whole arrangement of that how they discovered electron and what was the cathode ray experiment. Okay, whenever you put very large voltage, you connect a very large voltage, okay, and do this setup, so then the electrons are going to emerge from this cathode and move towards anode. We call it as cathode rays. Okay, and they are made up of negatively charged particles only, and that's why we will say that electrons are negatively charged particles. Okay, next. Then determination of charge and mass of electron. What happens? Let's say we have one setup. So I'm like going to present this the whole setup. Okay, so like this is cathode, and if allowed, let's say we have electric field like this, okay, and magnetic field like this. So if we have, let's say, some arrangement of magnetic field like this, let's say N and S. So then what will happen when cathode rays are going to come from this side? So then one by one, when we, you can say, regulate our magnetic and electric field one by one, so then the cathode rays coming out of this cathode, okay, based on are going to hit, let's say, this B target. Okay, so there's a target here, okay, and they're going to hit here, coming directly to hit B. Okay, when only electric field we are going to switch on and there is no magnetic field, let's say, so then these cathode rays are going to, you can say, come like this, and then from here there will be a deflection and they are going to hit, let's say, at A, okay, and when only magnetic field is now there and there is no electric field, so then they are going to hit at C. Okay, so when I was saying that when there was no electric, no magnetic field, so then the cathode rays are going to hit at B. When there is only electric field, no magnetic field, then they are going to hit at A, and when there is only magnetic field and no electric field, then at C. Okay, now, so there is, we can say that only electric field and no magnetic field A, only magnetic field, no electric field C. But then we can regulate both of these or not, both of these magnetic and electric field, to get it hit at B only or not. Like B, we can say that initially when there was no electric and magnetic field was there, so then this cathode ray was coming and hitting at B. Okay, but we can also regulate our electric field and magnetic field values or not. Okay, and allow it to just like come back and hit at B only. Okay, while doing that, we can say that there are two properties associated with electrons. Okay, one is electric charge and other is mass. Okay, we'll be able to determine the ratio of these charge to mass of electron or not by with the help of this experiment. Okay, and that's how, okay, charge to mass ratio of electron is determined. Clear? Okay, now what happens? Yeah, so after this charge to mass ratio, hmm, then Millikan came and Millikan did his experiment to determine the charge of an electron. So what he did was like very simple experiment. Okay, let me show this to you. Okay, wait. Millikan's oil drop experiment. So what he did was like put a chamber, let's say, okay, in which there is like there are like two positive and negative plates. Okay, and then he connected wait he connected one you can say atomizer. Okay, you can press it and which is filled with oil, oil inside. So when oil drops are going to come, okay, so there's this is like, let's say, uh, negative charge and this is positive charge. Okay, so while crossing through this negative charge, this oil is going to have carry some charge with it or not. Okay, and let's say this is the oil drop, this is oil drop. Okay, and what then, yeah, what he did was he balanced this whole gravitational force of gravitational force mg. Okay, is coming down, is pulling the oil, okay, downwards, and this electric force is due to the charge on this oil. Electric force is there, and this electric force and gravitational force, they are going to balance, okay, each other, and this oil drop is going to suspend in air like this, floating in air. So by doing this, what he did was he balanced the electric force with gravitational force or not, and that's how he determined the charge on the electron. Okay, so charge on electron is balanced by Millikan's oil drop experiment. Millikan's oil drop experiment. This was Millikan's oil drop experiment. Okay, and charge of electron was determined with the help of Millikan's oil drop experiment. It was found that charge of electron is minus 1.6 into 10 to the power minus 19 coulombs. Okay, and we already know uh, this charge to mass ratio, and now when the charge of electron is known to us, okay, is determined, so then we'll be able to know the mass of the electron. Okay, so with the help of these simple experiments, okay, Millikan you can say determined the mass and charge of electron separately. Okay, then yes, the mass of electron was determined directly by combining these two measurements, this and this. Okay, we will combine the results of these two measurements, these two experiments, and then we'll be able to determine the charge as well as mass of the electron. Okay, I hope that you got it. Okay, now some questions. These are the simple facts. So what we learned is, we learned about cathode ray experiment. Okay, what was the whole setup and what was the, you can say, observation and the conclusion. Okay, uh, from cathode ray experiment. So then we did the whole setup and experiment, okay, where these cathode rays are generating from this cathode, coming directly and hitting at B. Okay, when only electric field is switched on, no magnetic field, then they are coming to hit at A. And when magnetic field is switched on and no electric field, then they are coming to hit at C. Then by regulating these two values of electric field and magnetic field, okay, and letting it hit at B only, okay, we'll be able to determine the charge to mass ratio of electron. So now we know charge to mass ratio. And then Millikan's ion drop experiment, by this experiment we'll be able to know the charge of electron and mass of electron separately. Okay, now let's come to these questions. On the basis of Thomson's model of an atom, explain how the atom is neutral as a whole. So like we not yet learned the Thomson's model of an atom, but in any of the model of an atom, okay, we can say the atom is neutral. Why? Because the amount of negative charge, okay, is balanced by positive charge. Okay, like the amount of positive charge. So in any atom, in any neutral atom, the amount of positive charge will be equal to the amount of negative charge always, and that's why the atom is neutral. Okay, okay, so then it is asked, helium atom has an atomic mass of 4 unit and 2 protons in its nucleus. How many neutrons does it have? So we already learned that in the previous class, that protons and neutrons are responsible for masses, while electrons and protons are responsible for charges. So since it has it's this question says that there are, like, the mass is 4 unit, out of which 2 units are coming from protons, so it means 2 units will be coming from neutrons. So there will be 2 electrons. Okay, see, 2 neutrons, sorry, not electrons. Okay, so thank you, everybody. Keep learning from Ask IITians. I hope that you enjoyed and learned few new things in this lecture. And we are coming with lecture 3 of this series. Okay, thank you. If you have, yeah, if you have any problem, any doubt, okay, you can post it on the forum, or you can ask directly, okay, here in public forum, or in private forum. Okay, so if you have any doubts, you can post it. Okay, you can also connect with the various, you can say, tutors at Ask IITians, okay, through this, and we'll be responding to your queries and we'll be answering all your doubts. Okay, so thank you for your time, and keep learning from Ask IITians. Yeah.